you some time that I wish I had saved. Now, it might not be any news to you that in some recent changes, there's been some additions to how the secure port works. Namely, in the changelog for 112, if you search for the port 10257, you'll see that that is now the controller manager's default secure port. You can change this port number by using the secure port flag, but if you do nothing, it will allow you to use this secure port automatically. Now, if we go into changelog 1.13 and search for the port 10259, you'll see that this is the Kube-Scheduler's default secure port, similar to the controller manager, just on a different port that we can access. So going back to my terminal, I want to show you the cluster that I have set up. If we look at the pods inside of the cluster for a moment, you will see that this is a pretty standard Kubernetes cluster. Now, this cluster was bootstrapped with Kube-ADM. I haven't done anything fancy to change it around. It's using Calico as a CNI plugin. And the first focus point we're going to look at is the kube-controller-manager. And I'm just going to focus on that, although the semantics for the scheduler should be quite similar. Now, you'll notice that it's accessible on this port, which is actually my host's port in this case, since it is using host networking. And I'm going to go in and start querying this on the secure port. So based on what we just saw in the change log, if I come into that IP address and query 10257 at the address or URL health-z, I can hit the health-z endpoint. And if you look in the manifest for the controller manager, you'll see that it hits this endpoint. Now, in particular, something I found interesting that was a little bit different from how the API server works. If we look inside of the location of this, which is etc Kubernetes manifests, and this will be kube-controller-manager because Kube-ADM bootstraps it as a static pod. If we come inside of here and look at health-z, you'll notice it's actually going over the insecure port on 12.0.0.1 health-z HTTP. Now, this is bound to localhost, so it's probably not that big of a deal, but it might be ideal for this to actually get changed in the future such that it uses HTTPS for hitting health-z, which is actually what the API server currently does. I haven't thought that through too much, but just something I wanted to point out in case you do some digging like I did. All right, so we can query HTTPS for health-z. It works fine, which is fantastic. Now, similarly, we should be able to do this for the metrics endpoint, which if you look into the scheduler and controller manager, this is a URL that should just be accessible inside of it. So we go ahead and we curl that. Now, we're getting an error coming back, particularly an internal server error, and it's letting us know that we weren't able to submit a subject access review object. Now, this is the first thing that threw me off when I was diving a little bit into how all of this works. So what I did is I went into the pull request for enabling the secure port for 1057 and just basically looked through the test cases that were written to validate this functionality. Now, what I found inside of here was a particular cluster role binding that had gotten set up, and I'll dig through and find it. Okay, here it is. That basically took the kube-controller-manager user account and set up a cluster role binding that attached it to this system auth delegator. Now, I actually didn't know a whole lot about this whole auth delegation. I knew conceptually what we were trying to do, especially with like aggregate API servers and so on, but I didn't dive too deep into this. Now, as you could probably guess, based on just this message here, that particular role binding is going to give us access to create these types of objects. And basically what subject access reviews allow us to do is to offload or delegate the authorization for the requester to the API server. So effectively, if we were to make this curl call again and provided some bearer token that identified us as a user, perhaps containing like a service account token, we could actually send that to the controller manager. The controller manager could delegate the authorization to the API server as long as it can create the subject access review. The API server can assess should that service account be able to access that, in this case, URL resource, which is /metrics. So you'll see how all this pastes together in a moment. Now, I've got a couple files here, and they're actually also on my website if you want to check out the description of this video, if you want to copy and paste and follow along, but I will explain how they work. The first file I'm going to show you is a cluster role binding that I've set up, and it's effectively what you just saw in the code a moment ago. I'm going to take my controller manager user account, and I'm going to provide it a cluster role binding to the cluster role auth delegator, giving it that subject access review object the ability to be created from this controller manager. So that'll be the first thing we do to provide the delegation piece for authorization. So we're going to take this exact same YAML and we'll go ahead and apply it to the cluster. All right, so we've created that. Now, if we do the same curl request again against metrics, we still fail, but it's clear we're getting a different and better, in this case, result. So what this is effectively saying is, hey, I know you want to get the metrics resource or URL, but I'm not going to provide that for system anonymous. Now, where did it get system anonymous from? Well, obviously, I've not provided a bearer token inside of my curl request, so I'm really not presenting myself as anybody. I'm just going and hitting this port and say, give me metrics. Now, you might wonder at this point, why do you have to do this for metrics and not for the health Z endpoint that I showed you moments ago, where effectively it just went through and allowed that to happen? Now, what's interesting, if you read the docs for the controller manager, and if you go to that doc page that has all of the flags for the controller manager, you'll see this in plain text, which will effectively say that by default, authorization is always allowed for the health Z endpoint. That's just how it works. No need to delegate authorization at all. Now, every other endpoint we ever try to access, it's always going to go out and try to see, before it even attempts to hit this URL, to see whether you have access. So if we were to come in here and say AABBCC, we're going to get the exact same result because we never even got past the authorization step itself. Now, you kind of have two approaches you can take here. One is you could go into the controller manager and you could add that automatic authorization flag. You could include both health Z in it, and then you can actually put a comma in and do /metrics. Now, assuming you've looked it up and chosen the right flag, this will basically mean metrics won't require the authorization either. Now, this would be fine and would allow us to go over HTTPS, but it seems kind of logical to ensure we authorize ourselves when hitting metrics, because in my case, I just want Prometheus and its service account to be able to access metrics. I don't want anybody with system access who can hit this IP to be able to start scraping metrics off of my core system components. So I actually want to keep this as is. Now, the next question will, of course, be how do we give ourselves access to this? And that's going to be the second file I want to show you. So if I go into this service account metrics YAML file, it's a little bit more complicated, but still not too bad. Basically, we're going to create a cluster role, which I'm calling secure metrics scrape. It's going to have a rule for non-resource URLs, which is the /metrics endpoint in this case. And it's also going to provide me the get ability. So I'm going to ensure that anybody who's bound to this has access to get this metrics URL. Now down here, I've also included the cluster role binding for simplicity. You'll see that this cluster role binding is referencing the same cluster role, secure metrics scrape, that's above. And in this case, for simplicity, I'm going to provide access to the default service account in the default namespace. So as long as I get the token for that default service account in the default namespace and send it with my curl request, I should be able to get metrics out of that endpoint. Now, this is just for an example and to show you how things work. If you were to dive into how Prometheus is set up, you'd actually probably use some type of Prometheus service account and have Prometheus send its service account over as the token, which you can look in their docs for how to do that. But for now, we'll just focus on the default account and ensure it has access to metrics. So if I come in here and apply this same file, which was svc account metrics, send that over. Now I've created the cluster role and the cluster role binding. Now there is one more thing I need to do. And if you do some searching in the Kubernetes docs, you'll find that they have an example for how to grab a token for a user out of the secret and how to then use that in an actual curl request. So if I come in here and I just put it in a text file, you can again grab this from the Kubernetes docs and grab this token command here. I've already got it set up for what I need. It's going to grab kubectl describe secret out of the secrets in the namespace default for the user default or service account default in this case. So I'm going to run this command here for token and I'll echo it out to make sure that I have my token in place. So there's my token that's going to get sent over as a bearer token. All right, now sending the actual bearer token over. I'll send the token over by sending the same curl request in that we did before. But this time I'm going to put the header in for authorization bearer and have the bearer token variable in here as well. And of course, this is going to go against the metrics endpoint in this case. This time when I hit enter, you can see it's actually bringing back all of the scrapable pieces from the metrics endpoint. So now we have access to scraping metrics on the secure endpoint. Now, if we look inside of the Prometheus operator repository, there is a contrib folder inside of here, which has a bunch of manifests that we can take a look at for Kube Prometheus. So we'll take a look at the manifest for just a moment. And namely, I want to take a look at the API server manifest, and I want to take a look at the kube-controller-manager manifest. So I've got controller manager in the top, and I've got API server in the bottom. So you can see based on the API server how it's normally set up to provide the bearer token file, which would effectively be the service account that's added into this location on its particular container, and that it's going over the port HTTPS in this case. So you can kind of use how it interacts with the API server as an example for how you could update this service monitor for the controller manager so that it similarly goes over the protocol HTTPS in the HTTPS port for that service, along with providing the ability to have the bearer token file send across. Once you've got a conception of how this works behind the scenes, and as you've seen that the RBAC is set up correctly to allow the call, it's easy to see how the service monitor can be configured as such. The last thing I'll leave off with, and I haven't gotten the chance to dig too deep into why it does this quite yet, but you might remember that the scheduler and the controller manager have similar semantics, although the scheduler is on 259. Now, I haven't looked too much into the scheduler's default RBAC. Maybe there's a role binding I'm missing somewhere. But one thing I did notice is without any modification to the scheduler at all, I haven't done any, the scheduler, oops, let's make sure we don't try to verify. So the scheduler does not need to have that additional cluster role binding added that I needed for the controller manager. So again, in other words, you can see it's already sending those subject access reviews out to do the authorization, and I have not modified the scheduler at all. So just a bit of an inconsistency to be aware of, but now that you've seen kind of the worst case scenario with the controller manager, you have a pretty good idea of what all the pieces are that fit together to allow you to interact with this secure port. So again, I'm Josh. I hope you found this to be pretty helpful. Check out my website, which is in the description if you want a text-based walkthrough of these steps. And that's all for this video.